Welcome. The purpose of this video is to make sure that the reverse power rule for anti-differentiating power functions is some of the skills that are related to it, and talk about some of the other stuff as well. So it's kind of like a basics overview, if you will. So the first thing when working with power rule, whether we're doing differentiation or anti-differentiation, is to get the function in power form. So if we have any radicals in our equations, we're going to want to convert those into exponents right away. So in the first case, and of course I wrote the problem down wrong, this should have been 3 times the square root of x cubed. So if I have 3 times the square root of x cubed, I'm going to write f of x equals 3 times x cubed, and then the square root is to the 1/2 power. Now we don't usually write this. Usually we know that power of a power, we multiply these together, and 3 times 1/2 is 3/2. One way to remember this then is that we have x to a power, and if there's a fraction power, that's the root part. So this x to the 3/2, I'm going to read it as x to the 3rd power square rooted. So it's a good way to keep it straight. We have roots on the bottom and powers on the top. Anyway, for the antiderivative then, first thing I'm going to do is make sure I can do some mental math. Can I add 1 to 3/2 in my head? That's 2/2 plus 3/2 is 5/2. So that's what happens when I add 1 to the 3/2. And to get the antiderivative then, I use capital F of x, and that's going to be the 3x, but it's going to be to the new power 1 level higher, so that's 5/2 instead of 3/2. And then of course divide by that fraction. At this stage in our mathematical career, we should be more comfortable with dividing by fractions, but in case you've forgotten that when you divide by a fraction like 5/2, you can just multiply by its reciprocal 2/5. Another way to look at it is I'm going to take the top and bottom and multiply by 2. So 3 times 2 is 6, and 5/2 times 2 is 5, and we end up with the 2/5 times 3 is 6/5 times x to the 5/2 power. Again, if we want to put this back the way we found it, I had 6/5 times a radical expression, or I had 3 times a radical expression, so now I'm going to have 6/5 times a different radical expression. 2 is still the root, and 5 this time is the power, so this is 6/5 square root of x to the 5th power. You can simplify that further, but we won't worry about that today. Down here, then, same difference, same deal. It is radical form. I need to convert this into power form first, and hopefully you should be able to manage the shortcut. We're going to have 2 for the numerator of the exponent, 3 because it's a cube root, and negative because this variable is in the denominator, so negative 2/3 power. Got to keep all that stuff straight. So remember, the root makes the denominator of a fraction power. Negative means we are in the reciprocal mode, or we're in the denominator to begin with, and the 2 represents the original power. If you add 1 to negative 2/3, you get positive 1/3. So when I take the antiderivative, I'm going to keep the 5, keep the x, but this time raise it to 1 level higher, it's 1/3, and then I divide by 1/3. Again, hopefully we know dividing by 1/3 is really multiplying by 3, so we're going to get 15 x to the 1/3, aka 15 cube root x. Quick reminder about trig. We're going to look into some trig integrals more later, or antiderivatives later, but for now we just want to know the basics. And so there's only some stuff that we know by recall, and that's the only trig I'm going to be giving you guys. So if we have to remember that the derivative of the tangent is the secant squared, then we should know that the antiderivative of a secant squared is going to be a tangent. That doesn't change when we have a coefficient, because remember the coefficients can basically just stay put. So 4 times the secant squared of x, the antiderivative will just be 4 times the tangent of x. Again, that should be obvious. If you were to differentiate 4 tangent of x, this is going to be a result. So this is just a matter of recall. You'd have to remember your facts and reverse them from when we studied derivatives. For e to the x, this is sort of jumping ahead to some reverse chain rule stuff, but it's going to get you in a good place. So quick recall, if I take the derivative of e to the x, it's self-derivative, which means the antiderivative of e to the x will be e to the x as well. You have to remember a little trick here, though, because with the chain rule for derivatives, working with e to the 5x, we have to remember to multiply by the derivative of 5x, giving us the result 5 times e to the 5x. So here's an extra 5 that we multiplied when we took the derivative. If I was going to take the antiderivative, instead of multiplying by the 5, then I'm going to divide by that 5. In other words, to get the antiderivative of e to the 4x, we're going to take e to the 4x, and then this time instead of dividing by the slope, instead of multiplying by the slope, we divide. So this is going to be 1/4 times e to the 4x. Of course, if you checked it and you used the chain rule properly, you get 1/4 e to the 4x, take the derivative, it's going to be 1/4 times 4 e to the 4x, and the 1/4 and 4 divide out, and we just get e to the 4x. So it's going to take a little while to get your mind adjusted. We're just going to reverse the derivative process. So if you manage to nail down the derivative process for e to the x, again, just reverse it. We divide instead of multiply by the coefficient on x. Same even if the coefficient on x is a fraction, the antiderivative of e to the 1/2 x is e to the 1/2 x divided by the x, or the coefficient, and when you divide by half, it's multiplying by 2. So make sure you check your work when you do all of this. Again, for this particular video, I did not check my answers because I know they're right, but when you're doing your work, it's imperative that you double check and make sure that your final result here is the correct antiderivative. I showed you how to do that in the previous video. If you're not checking, then you could be reinforcing mistakes over and over, and that's not good. All right, quick note about the power rule. Again, no problem here if I have f of x equals 1 over x squared. No problem getting f of x equals x to the negative 2 power as a power form. Then the antiderivative is going to be raise the power by 1 and then divide by the new power. Or in other words, negative 1 times x to the negative 1, or negative 1 over x. So that's all stuff that we should know how to do. That's the reverse power rule. And my question is, what happens when we get here and we try to reverse the power rule? Because f of x is 1 over x. This gives us x to the negative 1 power. And if I were to try reversing the power rule, go one level up from negative 1, that's 0, and then divide by 0, well, you can't divide by 0. So something's wrong. So we have to remember that the derivative of the natural log was actually 1 over x. And if we're going to reverse that rule, then the antiderivative of 1 over x is going to be natural log of x. So this is something you're going to have to remember. So if you see 1 over x and you're asked to find the antiderivative, you just do big F of x equals natural log of x. It's easy as that. It's a recall. Now I'm putting x in absolute value. That's going to be explained more later. I would do that in class if we had one. But right here, just put the absolute values now, and we'll talk about that more some other time. Over here, then, 1 over x plus 3 is in the form 1 over x because it's 1 divided by a linear function. Whenever you have a constant divided by a linear function, that's fodder for the natural log antiderivative. So 1 over x plus 3 is going to antidifferentiate to f of x, or equals the natural log of absolute value x plus 3. 3 over x minus 2 antidifferentiates to be 3 times the natural log of x minus 2. So there again, make sure you check all these using Desmos, and this should be enough to help you with the next section of homework, which will be described on Power School Learning. So hopefully this is helpful, and have a great day.